Assalamualaikum warahmatullahi wabarakatuh, and hi. For today, our group will present about our group assignment for DAE 32403. It is electrical power system. We are from section 2 and group 7. Our lecturer is Puan Nadira binti Johari Halim Shah. For our group members is me myself, Muhammad Haikal Hashim bin Abdul Walit. My number matrix is AA191375, and my friend is Muhammad Hazmie Naim bin Ahmat Kamil. His number matrix is AA191646. So for the first slide, I will present about the type of generation system. We have 4 type of power generation system that we will discuss. For the first power generation system is solar power generation system. Second is oil power generation system. The third is wind power generation system, and the fourth is the tidal power generation system. For solar power generation system, the solar power generation systems are any energy system that is powered by the sun. The solar panel collect and concentrate the sunlight to produce the high temperature heat that needed to generate electricity. The solar power generation system have a solar energy collector with two main components. It is a reflector and a receiver. The reflector is act as a mirror that capture and focus the sunlight, and the receiver will receive the sunlight from the reflector. Often the solar power generation system have tracking system that keep sunlight focus onto the receiver throughout the day as the sun change position in the sky. Solar power system may also have an to electricity by using the aerodynamic force from the rotor blades. The air pressure on one side of the blade lower when wind blow across it. When there is a difference in air pressure and on opposite side of the blade, lift and drag will create. The force of the lift is stronger than the drag and cause the rotor spin. The rotor connected to the generator either directly, drivetrain, or through a shaft and a series of gearbox that speed up the rotation of a generator, allowing it to be physically smaller. The advantages of wind power generation system is free energy from the nature. It is wind, low operating cost, and lastly space efficiency. And for the disadvantages is wind energy is intermittent, cause noise pollution, and lastly cause some negative surrounding environment impacts. And lastly, we got the tidal power generation system. The tidal power generation system are the same as a wind power generation system, but unlike wind generator, the tidal generator are positioned underwater. The tidal power generation system are using tidal energy to generate the electricity. Tidal energy is created by using the movement of our tides and ocean, where the intensity of the water from the rise and fall of the tides is a form of kinetic energy. Tidal power is a type of gravitational hydropower that generate energy by using the movement of water to drive a turbine. Tidal steam barrage and lagoons are all example of how tidal can be controlled. Turbines are built in tidal steam for most tidal energy source. Tidal create tidal steam which are fast flowing bodies of water. Tidal product fast flowing body of water referred as a tidal stream. Turbine is a mechanical device that extract energy from a fluid flow. This fluid can be either air, wind, or liquid water. The massive dam known as a barrage is used in another form of tidal energy generator. Because of dam is low, water can spill over the top or through a turbine in the dam with a barrage. Barrage can be constructed across tidal river, bays, and estuary. The final type of the tidal energy generator involve the construction of tidal lagoons. Tidal lagoon is a body of ocean water partially surrounded by a man-made barrier. Fresh water empties into tidal lagoons, which are also referred as estuaries. The advantages of a tidal power generation system is free energy from the nature. It is the tidal energy. The second is the generator is more efficient, and lastly is clean energy. For the advantages is initial construction cost is very high. Have a few suitable site for construction barrage, and lastly is effect on animals and plants living near the tidal station. So for the second slide, I will explain about the electrical power system in Malaysia. So the national grid of Malaysia is a Peninsular Malaysian High Voltage Electric Power Transmission Network. Tenaga Nasional Berhad (TNB) on the operates it through its transmission division. The system is running the length of and breadth of Peninsular Malaysia, carrying electricity in bulk from TNB own power producer and IPPS to distributor. The grid also transfer major industrial client directly. More than 420 transmission substation in the Peninsular Malaysia with a total installed capacity of 5,305 MVA are linked together by approximately 21,000 circuit kilometers of overhead line and underground cable operating at 100,000, 22,275 and 500 kilovolts kV. The 500 kilovolt kV transmission system is the Malaysian's single largest transmission system ever built. The completion of this interconnection allow the electricity transmission to the load center, which is located in the Klang Valley area of Peninsula Malaysia. The electrical power system in Malaysia is a complex interconnection system because to reducing the reserve generation capacity in each area. The grid interconnection offer to the most efficient use electrical force while also ensuring supply security. It makes the system more cost effective and dependable. If a zone experience an unexpected rise in load or a loss of generation, it borrow from another connecting area. However, a certain amount of producing capacity known as the spinning reserve is required for network connectivity. The spinning reserve is made up of a generator that is running at regular speed and ready to provide power at any time. The interconnection between network is mainly classified into two types: the HVAC link and HVDC link. The HVAC is a high voltage alternating current interconnection. In HVAC link, the two AC system are interconnected by an AC link. For the AC system to be connected, each of the two systems must have sufficiently close frequency control. The AC link establish a firm connection between two AC systems that are to be linked. However, the AC interconnection has several drawbacks. While the HVDC is a high voltage direct current interconnection, the HVDC is a DC interconnection or DC type provides a loose coupling between the two AC systems to be interconnected. Non-synchronous DC connection between two AC systems and synchronous. That's all from me. We will continue another slide with our another group members.
Right, I will continue for the question C. Okay, first we have generator. Generator is a machine that converts any mechanical energy into electrical energy. It's also called as dynamo. The source is primarily from the rotating turbine, comes from variety of different sources such as hydraulic, solar, steam, coil, combustion of fossil oil or nuclear fission. The working mechanism of a generator is by capturing the power of motion and then changing it to electrical energy by forcing electrons from the external source through an electrical circuit. This is the motor. It consists of three major parts, namely as rotor, stator and also stator winding. Next, we move to the power transformer. Power transformer is an electrical device that can transfer power from one circuit to another through electromagnetic induction. Power transfer without any alteration on the frequency and remain unchanged, which is 50 to 60 Hz. Power transformer is a one kind of transformer that is used to transfer electrical energy in any part of electrical or electronic circuit between the generator and the distribution primary circuit. It can interface with the step up or step down voltage. Power transformer can be classified into three types based on the range. Okay, first we have range of small power transformer. It can be from 500 to 7500 kVA. Second is medium power from 7500 kVA to 100 MVA. And last one is large power transformer. It's from 100 MVA and beyond. Okay, this is the power transformer part. We have transformer tanks, high voltage bushing, low voltage bushing, cooling fins or radiator, cooling fans, conservator tanks, system ground terminal, drum valve, dehydrating breather, oil temperature or pressure gauge, bushing, current transformers and also control panel. Next, we move to the transmission line. The transmission line is used to transmit electrical power from generating substation to the various distribution units. The distance between the line and the ground is much higher due to the safety purpose. For transmitting high voltage over long distance, high voltage direct current is used in the transmission line. The performance of transmission line mainly depends on four major parameters denoted as resistance, inductance, capacitance, and shunt conductance. Next, move to the substation transformer. A substation transformer is designed for installation on three-phase transmission and distribution system. It is constructed for indoor and outdoor mounting on a concrete pad. It can be defined as transforming, conversion, transmission or distribution substation. The advantage of substation transformer is advanced water cooling system, powerful and compact go well together, impedance reach losses, and control of hotspot and excessive losses. Next, we move to the distribution transformer. A distribution transformer is also called isolation transformer, used to the high voltage to the normal voltage like 240 volt to 120 volt to use in power distribution in an appropriate rate. There are four types of distribution transformer connection available like star to star, delta to delta, star to delta, delta to star, and zigzag or delta zigzag. The application of distribution transformer is the transformer changes from high voltage electricity to low voltage electricity. The main function of this is to step down the voltage to provide isolation between two windings like primary and secondary. The transformer distributed the power to remote areas which are generated from the power plants. Okay, the last one is loads. We have three loads: residential load, commercial load, industrial load. Residential load uses electrical energy for doing residential work like home appliance, lighting load. Residential load are uncurtained. They vary with time of day. At morning, evening, residential load are at peak value. Next, the commercial load occur for longer period compared to residential load. This type of loads are mainly electrical energy utilized for commercial shop, school, college, advertising, hoarding, malls, elevator or cinema halls. Next, industrial loads. Industrial loads have constant demand and considered as base loads. Commercial loads are little affected by seasonal variation and weather conditions. This load mainly include industrial appliances like motor, furnace, cranes, industrial lighting, computer, elevator, and also pumps.